Hello, everyone. Welcome to our webinar today with Bethany Lockhart Johnson, Defining Math Fluency, what fluency really means and why it matters. We're so excited to be here today. And while we wait for people to join, why don't you tell us where you're at, what you do, and what's something that you're fluent in, whether it's math or something that like a language or a skill, like what's something that you're fluent in or trying to be fluent in? The chat picked up really quickly. So excited you're all here. Can't even keep up. All right. Well, while we're getting ready, we'll go over some housekeeping tips to make the most of today's webinar. So to get the best experience, post in the chat to join the live discussion. We'd love to hear you as we go. To ask a question, you click on the question mark icon and we'll have a dedicated Q&A at the end. Close other applications so that way everything works well, you don't get any freezes. If you have audio issues, please refresh your browser window. That usually helps. Also, you can disable pop-up alerts from the chat. That's always helpful so you don't get the little pings every time someone chats something. And for live captioning, closed captioning, more tips, you can visit this link right here, home.edweb.net/edweb-tips. Also, join the EdWeb community. It's free. This is how you get your wonderful CE certificate after you attend the webinar. You can also access all the recordings, CE quizzes, slides, and resources from other Ed webinars. And now it's time to introduce Bethany. As many of you may know, she is our wonderful co-host of Math Teacher Lounge with Dan Meyer, and we love her, love working with her. She's an elementary school educator, curriculum design consultant, and author. She's committed to helping students find joy in discovering their identities as mathematicians. She has a long history, especially with math anxiety. We just had a webinar with her earlier this year, and that was our whole season 5 of Math Teacher Lounge. It was wonderful and super, super illuminating. In addition to her role as a full-time classroom teacher and our wonderful podcast host, she is a Student Achievement Partners California Core Advocate and is active in national and local math organizations. She's also a member of the Illustrative Mathematics Elementary Curriculum Steering Committee, which was a mouthful for me to say, and serves as a consultant creating materials to support families. So without further ado, Bethany, I'll kick it over to you.
Hi, how are you? Can you hear me okay, Shannon? Okay, great. So today I'm Bethany Lockhart Johnson. We're talking about defining math fluency. And I want to kind of tweak it a little bit. It probably should have said defining math fact fluency. One thing I love is we're currently in the thick of season 6 for Math Teacher Lounge, and it's all about fluency. And our first guest was Jason Zimba, who helped to co-write the Common Core state standards. And he did a beautiful job reminding us of fluency being bigger than just math fluency being bigger than just the facts, math facts, or your basic operations. He was reminding us about how, like, when we have kiddos counting, you want, like in kindergarten, kiddos are trying to build fluency counting out loud, counting to 100. When I have a toddler, we're not yet tying shoes, but another guest of ours, Val, reminded us like that fluency can be anything, tying your shoe when you think about fluency. So as we're kind of diving into what fluency means, I want to reiterate that what I'm going to be talking about today is math fact fluency, but I also want us to hold this like umbrella definition of what fluency looks and feels like. So Shannon already introduced me, and I taught most recently. I was teaching kindergarten. Now, again, I'm co-host of Math Teacher Lounge podcast. I live in Southern California, and so when I'm talking about standards, we are a Common Core state. So I'll be talking about California Common Core state standards, but it's uh, I think it's definitely applicable whether you're using Common Core standards or not. So, also another thing I want to help frame for our conversation is that when I talk about students, I'm talking about students in through the lens that all students need and are worthy of multiple rich opportunities to engage in problem solving and sense making processes. All students are capable of making sense of a given context. All students bring a tremendous amount of knowledge and schema to the math classroom, and all students are influenced by your disposition of mathematics and your classroom environment. So, Shannon asked, what's something you're fluent in? And I think it's a good reminder to think about something that you're fluent in, that when you're doing it, the how, the strategy, the work, that part isn't entering what you're doing, isn't entering your conversation. I started piano about 2 years ago, which if you wanna say something I am not fluent in, but it's been a really beautiful exercise in remembering how, like, learning a new skill can feel really fumbly at first, but when you get that one part or that one chord or that one, your finger just knows where to go, the mental load and the mental work that you were putting into it in order to like play a piece, that piece that you now own that you're fluent in, you don't have to think about that anymore. It's just a part of you. And so sometimes when we think about math fact fluency or reading fluency, when we think about why is it important to be fluent, sometimes we can forget how it feels when you are fluent in something and when you're not. So, what does that have to do with math fact fluency? It's that a lot of time math facts serve as the gatekeeper between a student feeling like they are capable and able to do and engage in mathematics and their relationship with math is deeply affected by whether or not they know their math facts. And I'm not being dramatic. I'm telling you, based on so many experiences with students, particularly in like third, fourth grade, or maybe they're not quite fluid in their addition and subtraction, and now they're being asked to learn multiplication and division, and they're not fluent, and it's really helping to define what they think math is. And they're using so much of their energy and being and to try to solve these basic math facts, they're not getting to like that juicy problem solving. They're not able to get past that hurdle without a lot of work. And so oftentimes students, it's the moment where students can decide that math isn't for them. And instead, I see thinking about fact fluency as really exciting because it's such a bridge to giving students access to all that wonderful like deep dives where you're not thinking about your multiplication facts, you're using them in service of solving these problems that are interesting to you and that are exciting. So today we're going to talk about, first I want to help, I already started, but defining math fact fluency and talking a little bit more about why it matters, thinking about how we can teach it. And the framework I'm going to use, I'm going to walk you through a part of the math fact fluency journey in my kindergarten class, but I think hopefully you will find that it's applicable to whatever grade you're teaching. Thinking about how we can assess math facts, and then talking about some next steps. What could you go do tomorrow? So again, I'm a co-host of Math Teacher Lounge. That's my co-host there, Dan Meyer. And back in season 3, we had an episode where we interviewed Dr. Val Henry and Tracy Zager and Graham Fletcher. We had two interviews that really helped us start thinking about fluency. And what we knew for sure is that we were not done talking about fluency. Like we were barely scratching the surface. So then when we were planning out our seasons, we decided that we wanted to, our season 5 was about math anxiety. And we decided that we wanted season 6 to be all about math fluency. So I want to shout that out because that's another great resource where hopefully you can dive into some episodes and listen to some of these speakers who think about math fluency all the time. And I want to give a special shout out to Dr. Val Henry, who was in that episode in season 3. and then has joined us again for this season. And Dr. Henry's work has completely shaped the way that I think about fact fluency, and her program Facts Wise really helped me understand the power of fluency. And so I really want to highlight her work and give credit that a lot of my thinking is deeply influenced by her work and her research. So, when we talk about students who are fluent, they solve problems accurately, flexibly, they utilize appropriate strategy, and they solve with efficiency slash speed. So when I say accurately, we obviously want students to get the answer correct, so it doesn't derail the rest of the problem. Flexibly, we want them to be able to use known facts, for example, to be able to like, I want to solve 13 minus 4. Well, I feel solid in my, I know that if I take away 3, I would get 13 minus 3 is 10, and I could take away one more to help me get 9. Using those, knowing how to compose and decompose numbers in a way that can help me to solve facts that aren't known. And they're all, and eventually become so automatic that that calculation, that moving around and decomposing, that just is a part of it. Like I'm not even thinking if I'm adding 9 plus 8 in my mind, I might say, oh, that could be the same as 10 plus 7. But that flexible moving around and decomposing of the numbers isn't something that I'm even really consciously doing because I'm fluent in that fact. Using appropriate strategy. For example, students know that making a 10 could help them solve a problem, or they might be able to use a fact that they know. Like, for example, if they're trying to solve 6 times 8, they might say, well, I know doubling. I know I can multiply 3 times 8 and 3 times 8, and then I could take that 24 and put it together. Now, again, we want them eventually to be fluent and just to be able to say 48. But as they're trying to build that strategy and really learn and own that fact, these strategies can help them. And finally, I really hesitate to put speed to anything connected to math because I feel like so often folks think if I'm not fast at math, then I'm not actually a mathematician. Or if math doesn't come easy to me, then I'm not a capable mathematician. And so when I talk about efficiency or speed, it's that you're not using a lot of that workload, that mental working memory in order to solve it. So when you're assessing students, you know they get it in about 3 seconds, but it doesn't mean that that's how they're getting it initially, and it doesn't mean that speed's the only indicator. So again, I'm using California Common Core state standards. So these are the fluency standards, starting in kindergarten, fluently add and subtract within 5. And then throughout, in terms of the 4 operations, by the end of third grade, they're fluent in those multiplication and division facts in second and third grade. So I want to call out as we're thinking about how we define fluency, the progressions for the Common Core state standards. This was in draft format back in like 2011. They actually just in, I think it's February, came out with like the final version of the progression documents. And it's such a rich resource because it's really talking about it was before the standard. So it was the foundation on how are these mathematical concepts developed and really help to shape how is the student understanding going from subitizing a number up to adding a number within just a couple months. They're able to see that 3. Well, now they're able to decompose and add and break apart that 3. So I'm going to highlight just a couple quotes from the progressions that I think are really important. They do say that fluent means fast and accurate, just knowing some answers from patterns, and knowing some answers from use of strategies. And it really highlights that fluency is going to be a mixture of these kinds of thinking. Some types of strategies are going to work better for certain students. Another thing that the progression documents really highlight, I love that they say the practice with these facts are from deep, extended experiences students have with addition and subtraction in K and grade 1. And so often we might just assume that they'll just get it, right? Just by being in the space, they'll learn their facts, or isn't that happening at home that they're supposed to be learning their facts? And there is an element, we want some home practice, but in our classroom, how are we giving students deep and extended experiences with these math facts? And finally, I want to share this quote that this is not a matter, teaching facts and learning facts and building fluency is not a matter of instilling facts divorced from their meanings, but rather as an outcome of a multi year process that heavily involves the interplay of practice and reasoning. And that quote resonated with me because, again, really at the core is that sense making. And I don't just want to be able to say 2 times 3 is 6. I don't want to just like know the lyrics to that, right? I want to understand what it means to be able to represent it and to have it mean something. So I mentioned briefly that oftentimes math facts can be serve as like a gatekeeper, right? So when I think about the way that I want to create an environment in my mathematics classroom, I think a lot about a student's self concept, their competence beliefs, and the way that they feel that they are capable. Or do they feel like they are capable mathematicians? Do they feel like I might face a challenge, but I have a belief that I am able to learn and learn these strategies. So when in a paper that I'm referencing here, math self-concept was assessed using items such as how good students thought they were at math, how well they expected to do in the future in math, and how good they thought they would be at learning something new in math. And again, the lower levels of math self concept, the higher levels of math anxiety or anxiety in general. And the higher levels of math anxiety, the lower levels of self concept. And it was a real reciprocal factor. And so students were, when they're faced with these math facts, if they're feeling like that's the hurdle or that's the thing that they are not, they don't own those facts when they're presented with problems that require them to use it, and so much of their thought is going towards solving those problems, you're finding that students more and more are feeling like math is not for them. And too often we see charts like this like tracking in a classroom of the ice cream scoops or tracking of how far am I, or hey, when everyone gets up, this is from a classroom, and I'm sure a very well-intentioned teacher, right? This teacher said, I want to celebrate the growth that my students are making with their math facts. And so every time they know their facts, we're going to add another ice cream scoop. And at the end, we're all going to get an ice cream party, right? And this teacher, I can picture them being so excited about this project and working on it and cutting out the things and cutting out the images. And what I think about is the student who, let's say in the corner there, who knows their times zeros or their times ones, and their ice cream scoop is right next to the times five. So, what kind of a message are we sending about what it means to be capable mathematicians? And are we doing something that could inhibit a student's positive self concept? So, Dan Meyer again, and here my fancy MS Paint level graphics design. We did a winter wrap up, and we brought Val's episode back, and we were reflecting on fluency. And he shared this quote from Alfred North Whitehead: "Civilization advances by extending the number of important operations which we can perform without thinking about them. Operations of thought are cavalry charges in a battle. They are limited in number, they require fresh horses, and must only be made at decisive moments." And I'm going to admit, when he said that, it didn't resonate with me in the moment. But then I started thinking about working memory. I got, okay, that connection makes sense. And so this image that I had put as I was talking about what fluent students are able to do, I love that, like, this sums it up for me. This picture of this woman holding this box that I labeled math facts. It's like, it's not heavy. I've got it. It's in my toolbox. These are one of the many things I have in my math toolkit. And when I think about, I can perform these operations without thinking. And if I have to do those operations of thought, if I have to use a lot of my working memory to solve these math facts, again, it's preventing me from doing this richer problem solving and feeling like math is something that I feel is really for me. So I want to talk about how we can teach it. So, research, and here I'm sharing research from Dr. Val Henry in her program FactsWise. She says that research shares that effective fluency practice should look like it should be strategic, it should focus on sense making and building number sense, it should move from concrete, representational to abstract. It's based on research of how students make sense of operations. It's a consistent routine of 5 to 10 minutes a day. And in her work, she discovered that, she's learning a lot about long-term memory. And in order for these facts to get in a student's long-term memory, they needed to be repeated every 24 to 48 hours. So by having a consistent routine where you're doing these little mini bursts of fluency practice, it became something that the students became fluent. Teachers collect data on students' fluency through formative assessment opportunities and during one on one interviews. So, not time tests. And I'll talk a little bit more about that. So, I want to take you into my kindergarten classroom. And when I say that her research found that effective fluency practice has all of these elements, it's interesting because I have visited lots of classrooms where teachers maybe aren't consciously doing all of these things, and I don't and at any one point no one's doing all of these things to make the most effective fluency practice. But they said, well, some of my students are still fluent, or my students are still learning their facts. And some of them were getting extra practice at home, which it's great if they can have home practice. And some of the students it came a little easier for. But when we think about how can we make the most accessible learning opportunities for all of our students, when we think about how can we make this practice a practice that's meaningful and accessible for all students, this is what research says will make it most effective. So strategic, I'm thinking about what the fluency standards are and what they look like over the course of the year and where my students are going after this. What do I hope they brought into the classroom with me, and what tools do I want them to bring with them into their next grade? I really want them to be able to make sense of the problems and build their number sense. And the first example I'm going to give talks about that, moving from concrete to representational to abstract. So in kindergarten, the goal is fluent within addition and subtraction facts within five. So oftentimes, you might hear, if you have a kinder or you teach kinder, there five is a big deal in kindergarten. Not only are most of the students five, or have recently turned five, but they're also, most of us walk around with five fingers, right? So with our students, we want to think, okay, how can I celebrate fiveness and really help them to own five, and when I say own it, like they can decompose it, they can pose it, they can make it in all sorts of different ways. So to be as concrete as possible, one of the first things we started doing is we each student got a popsicle stick, and with their partner, they took their popsicle stick and they just said, well, where could I put the popsicle stick, right? If I put the popsicle stick here, how many fingers are on this side? Oh, I have one finger on this side. How many are on this side? I have four. And I'm not talking about addition and subtraction. I just want to know how many are on this side, how many are on that side. And then we did that and we shared and then we charted it like, ooh, could it be any other way? And I flagged the chart because this chart wasn't made and then I showed it to the students. This was a co-created chart. So the chart is a part of the student's experience and learning about this concept, right? We're creating it together. And this is a chart that's going to live in our classroom as we're developing our understanding of five. So in pencil, I had drawn the little hands because I didn't trust my on the spot hand drawing. And then as we're talking, we're drawing it and saying, a student was telling me, well, where else? And so this student comes up and says, oh, I had um, two on this side and three on this side. And so I've already planned out that because I want to build that structure for them of 0, 5, 1, 4, 2, 3, 3, 2. I've already planned out how I want the chart to go in order so that the chart can continue to become a strategic use to help them see structure. but I want their findings to be reflected on the chart. And then our next practice, they had Unifix cubes, and they each had 5 Unifix cubes. And what are the different ways that you could break them apart? Oh, okay. You had 1 in this hand and you had 4 in this hand. Oh, you had 3 and you had 2. And I remember vividly a student holding 2 in one hand and 3 in the other. And then she was switching them back and forth. She's like, wait, but I have 3, 2, 2, 3, 3, 2. And those little connections of I don't it won't serve her as well for me to say, oh, 2 and 3 is the same as 3 and 2. You could switch. She needs to discover that through that play and through that action of exploring with these tools. So then I took pictures of the students with their Unifix cubes and put them with underneath the hands to start building that connection. And I would ask them, well, in this picture, Julie has 3 in this hand and 2 on this hand. Where could that go? And students are, again, they're making it. It's co-created. They're helping to build this. And as we continued our fluency practice, that chart kept growing and growing. And again, I want it to serve as a tool that students can come back and reference. And if you see the students up there practicing, they're helping to explain it to us and to their classmates. Oh, well, this is the same as this. Or I had this sometimes the students who were actually pictured in the picture came up and said, oh, you know what? I found out if I put, because one that it took them a long time to get was 0 and 5. And they said, oh, if I put it over here, then there's none, but there's 5 on this side. So again, the students were owning this work because this is for them and it's not me telling them. It is co-created, and that public record is going to live in our classroom, and it's something again that they own and they're a part of, and they were there and know, oh, I remember that. Or you could say, oh, go look at the chart. What do you see? I want to flag too that when I shared about the Unifix cubes, sometimes it's just a small tweak that you're making. So, for example, in my classroom, instead of storing my cubes either loose, we had I had like a bucket of some loose cubes, but then for the ones that we were using for all of our fluency practice or for problem solving in the tool section, they weren't all in one color. They were in 10 sticks, and but they were 5 of one color, 5 of another. And that way, when students were going to access these tools, automatically, when we're working with 5, they would grab a 10 stick. And again, we're not in kindergarten, you're not calling it A10, you're calling it 10 ones. But they would grab that. The students knew, okay, this is 10. We talked about how this is 10. They had counted it, they knew it's 10. And eventually, you have students breaking it apart. They could easily see the color to give it to their partner. So that's something where I'm trying to plant that seed of that, like, oh, 5 and 5 is 10, and understanding, again, making understanding 10 pairs and understanding that a 5 can be a part of a 10. And these little tweaks that are just like, that becomes the norm. It's something the students own. And that's a little tweak that took, 2 minutes of sorting. So because my students did it, yeah, that's why it took so little. Another part is with math. I want to incorporate a lot of play. I want my students to incorporate games and um, these two examples you're seeing. One, the student has 5 Unifix cubes, and one they break it apart and they put some behind their back, and then they're showing it, and their partner has to tell them how many are behind their back. Or on the far picture there, there's students have um, cubes under a cup. And so you could do that with Unifix cubes, you could do it with bears and call it bears in a cave. I've seen all different versions of it. But the idea is students are starting to understand that 5 can be decomposed into parts. And if I see 2, then I know the unknown is 3. So these are all examples of the concrete. They're actually physically manipulating 5, moving to the representational. We're drawing images. I'm making a chart until eventually we're moving to more abstract. And some great references for games. I mentioned FactsWise. In an upcoming episode of Math Teacher Lounge, Jennifer Bay Williams was interviewed by Dan at the National Conference for Teachers of Mathematics. And they talked all about games and how you can incorporate games into your fluency practice. And then Graham Fletcher and Tracy Johnson Zager Graham created some wonderful games in their Building Fat Fluency kit. So all of these games, and plus online, I'm sure you can find more ideas. And if you need game ideas, I'll send you some game ideas. But the idea is students are engaging in play while making sense of these concepts. And so then that can translate to home practice because then at home, the homework is teach your parents how to play bears in a cave, five bears in a cave. Teach them how to play that. And then the parents are or the caregivers are feeling like they're able to practice fluency in a meaningful way that is also building connection. And that's what I want from that home practice. So I've mentioned a lot of representing structure. So another activity that we did with five students put five counters, the two-sided, two-color counters, into a cup, shook it, spilled it out on the mat, and then they put it on a 10 frame. And their only instruction was to put the reds first. What happens if we put the red ones first? Let's start and let's record what you find. So students recorded it and they're finding again those different ways to decompose and compose five. And then again, this is part of the standards for mathematical practice. And this is habits of mind that students are engaging in as mathematicians from K all the way through 12. Well, hopefully beyond, but within K through 12, they span all of the grades. And seeing structure and generalizing is one of the categories. So looking for and making use of structure is something that's huge. That if I tell a student if I just put up a chart that shows a structure, it's not going to have the same meaning as if the students are creating and discovering that structure. So then again, as the teacher, I already know how I want to chart it, but the actual charting is coming from the what's on there is coming from the students. So a student says, so I'm not this chart doesn't get filled in typically from top to bottom because a student may say when we go back to meet on the carpet and talk about the work we did at our desks, a student may say, "Oh, I got 3 reds and 2 yellows." So I'm coloring it in or putting I recommend actually cutting it out of construction paper because staying there and coloring the circle, anyway, learning curve, right? So the students are bringing that to me. And I keep saying that. I feel like I just keep saying that, but so often I feel like teachers it's easy to forget that, right? Because it's easy to forget that students are bringing this or students are can bring all of this to us, right? We're learning from them. I'm learning from my students how they're engaging with the work and how they're making sense of it. And so then another thing that I did with that chart is made a small version of it to then add to that larger anchor chart with the hands and with the pictures. So the students had a chance to place those. So they placed the 0 and 5 underneath the 5 and 0. So again, we're building that and building that. So moving from the concrete, actually holding and manipulating 5 to the representational, I'm recording what I found, to the abstract, where eventually we build it with number sentences. And something I want to talk about before I move on actually is again, when we talk about fluency practice, that game where students are doing bears in a cup or where students are uh, when they were doing the popsicle stick, that might be 3 minutes or 5 minutes. And of course, initially in kindergarten or anywhere where you're teaching the routines, it's going to take longer. How do we take out the Unifix cubes? How do we share the Unifix cubes with a partner? How do we find our partner? All those steps they take time to help create as you're creating your classroom community and your mathematics community. But then the idea is students know, okay, I know where my tools are. I know how to access my tools. Those tools are for me anytime I want or need them. And it's not going to go perfectly at first, but the goal is we're building this community together and we're learning how to work with this. And it will do me no good if I have all my Unifix cubes or my counters packed in a closet or only I get to use them under the dot cam or whatever. No, they're meant to be in the student's hands. And I want to figure out how can I do that in a way that acknowledges I have many, many students and acknowledging that um, that's what makes this rich, right? That's what makes it exciting and engaging is because students are so involved in every aspect of it. So a lesson like this, where with the color counters, where students are putting the counters in the cup, shaking and spilling, and then coloring it, that's going to be a longer lesson. But then maybe it's the next day that I come back and record it on the chart. If I've allotted 10 minutes for fluency practice that day, then we might not have time to do the whole chart. And that's okay. This is a repeated, deep, meaningful practice that is going to weave all throughout the year. Um, and I want to share a problem that um, a friend, colleague, Jody Guarino, and I worked on together. And I got the chance to present with another teacher, Tara Minton, who teaches in Southern California. And so we had a lot of fun trying out this problem with our students. And so you'll see Mrs. Minton's name, but Jody and I originally created this and really thought about how can this structure help students to see that five. So, and this was grounded in work from CGI, cognitively guided instruction, where it's really moving towards listening to the students and letting the students' knowledge and understanding inform the instruction. So in this problem, Mrs. Minton has 5 rabbits in her backyard. Sometimes the rabbits are in the hutch and sometimes they're out on the grass. Show the different ways the rabbits can be in Mrs. Minton's backyard. So this is the students, on the left there is a student sharing out. So a student drew the hutch and they show that there are 3 in the hutch and 2 out. And then I'm charting that and we're tying it back in to the work that we've been doing with 5. So eventually we had, like, as I'm planning the share out, as I'm walking around and seeing what students are coming up with, or as they're talking with their partner and seeing, well, did you find all the ways, or as students are moving Unifix cubes in and out of a paper, to kind of try to make sense of this for themselves. I'm noting, excuse me, I'm noting, okay, which answers could I share out? How can I be strategic in sharing this out? So again, I can build that structure of 5 in, 0 out, 4 in, 1 out, etc. And again, we're moving towards the abstract. We're beginning to build number sentences. But now, when the students are looking at these cards that have numbers 1 and 4, and they're making pairs, this is a game called Go to the Dump, where students have a set of cards, kind of like Go Fish, but they're trying to build fives. And this is from Val Henry's Factswise. They see I have a 4 and they need to ask for a 1. And if the partner doesn't have a 1, they have to go to the dump and take a card. Again, they're trying to build those pairs. But by now, by the time they're playing this, and this is something students can go play if they're finished with their work early after they've learned it, but by now they've had meaningful practice with these numbers. So showing them a 2, that means something now. They've had all of this repeated practice working with 2s and 3s with numbers. So a 2 and a 3 is going to mean something different when they're trying to create that 5. And I know, again, thinking about what's happening in first grade, I know that within first grade, I want them to be fluent in addition and subtraction within 10. In kindergarten, I just want them to, if I give them a 3, I want them to be able to find 7. I want them to be able to understand a pair that would make a 10. But I'm trying to find ways that that 10, that they can start composing and decomposing 10. So, for example, our daily attendance was these little folks that they put up on a 10 frame. As they walk in, they would put their magnet in and put it up, and they'd fill the 10 frames. So, again, we're counting by tens. They're seeing, oh, there's 23, and they'd see the 3. Well, how many students would we need to have to fill this 10 frame? We're doing dots for the day instead of just like writing down that today's the 50th day in school. We're filling it in with dots on a 10 frame. And then every day we're counting, because again, I want to build that fluency of counting to 100 and counting by tens. We're counting the numbers We're counting by tens, and students, these are up every day. So students are looking and they're seeing these 10 frames, and it becomes a tool, a regular tool, like a familiar tool. That's the word I was looking for. And again, like those little shifts, like taking those Unifix cubes and seeing that I can store them with the 5 and 5 instead of storing them loose or storing them in a 10 stick. Even that's helping to move towards that fluency within 10. And I know again that I'm talking a lot about kindergarten, but these same ideas, that's 'cause that's what I taught, and that's where I love K through 5, but again, those ideas, I'm still trying to be strategic. I'm still trying to think where can I support my students in whatever goal I'm doing, if it's multiplication, how can I support my students? And then think about where they're going to. And then later on in the year, we did this same problem and we brought back the problem, but now she has 10 rabbits. So what did that mean for students to have 10 rabbits, or for Mrs. Mitten to have 10 rabbits? And I'm showing an example here of all different levels of engagement. So I gave the students a picture that they could then move Unifix cubes on. So they would like move the rabbits in and out of this little hutch and onto the grass. And I told them that was her backyard, but it was Google image backyard. And then they're drawing it, right? They're just drawing it on there. Or where another student wanted to draw it out, make a number bond, make a number sentence, write about it, but but they're all practicing that fluency. And again, they're familiar with this problem. They know how to dive in, but now we're working on within 10 and they're using their knowledge of within 5 to help them solve that. So again, reminding that this research, effective practice, again, I'm trying, no matter what grade I'm teaching, I'm trying to be strategic. My goal is always sense making and having students really build that flexibility with numbers. I want to make the work as concrete as possible, moving to the representation and then representational and then the abstract. I don't want to start by handing them a flashcard. I want them to have deep, meaningful practice with, if I'm doing multiplication, with creating groups, creating with division. We're moving. We have the Unifix cubes. We're moving them apart. We're dividing them. We're dividing them onto plates. We're making sense of it in ways the tools are for all students, and too often, especially in upper grade classrooms, but as early as in like first grade, I see tools locked away. And a lot of times it's not, again, because teachers don't want their students to make sense of things, but it may feel overwhelming. And they may say, well, I've heard a lot of teachers say, but it's really messy, or the kids play with it. And all of those things are true, right? They're going to play with it. If I give counting bears, they're going to make the bears, whatever. They're going to build a Lego structure with the Unifix cubes. There's time for them to explore it. We have a tool talk, and we're slowly building the expectation of how we use these tools. And the students are starting to select tools in ways that are going to help them to solve the problem. And so again, the sense making, moving from concrete representational to abstract, and this amazing book, Thinking Mathematically. I'll share a quote from there. If students genuinely understand arithmetic at a level at which they can explain and justify the properties they are using as they carry out calculations, they have learned some critical foundations of algebra. So oftentimes, when you think about algebra and you're working with your kindergartners or your youngest kids, but it's all connected. And these ways of moving from, I'm directly modeling something, I'm using strategies to count things out, I'm using derived facts, I'm using facts that I know to help me understand and come up with facts that I don't know. It keeps building on it, and I just think that's really, really exciting. A few thoughts on adapting existing curriculum. These two examples are from Engage New York. So, in one example, there's a picture of a student holding up four fingers, and the worksheet wants you to circle. Would the to make a five, would you circle the hand with one finger up, or would you circle the hand with two fingers up? Well, instead of that, how about they face a partner and they do that same activity? Or in another worksheet, there's a drawn Rec and Rec. You can make or buy Rec and Recs. It wasn't in my budget this year. I made them with, this is a photo that I found, but I made them with a piece of cardboard and I wanted to have five on there. And then eventually we had 10. And instead of, sometimes worksheets are very useful, but I want to make sure, again, that's pretty abstract, right? Those dots on the page and they have to figure out the number. I want them to have had experience with that first. And finally, I want to talk about how to assess. How are we assessing in a way that enhances student self-concept and make it meaningful? And when I look at something like a time test, when the goal, if you see there, it says move fast, I may look at this and I may be able to score it quickly, and I may be able to see, oh, this student got them all right. Therefore, my student must be fluent. But we know from research that time tests are actually oftentimes linked with anxiety. And when you ask folks, when was a time you experienced math anxiety? Time test often comes up in the conversation. That feeling of panic, of not knowing, of feeling like they had to hide their fingers under the desk as they were trying to calculate, as going through and first, okay, I figured out 7 plus 2, so now I'm going to go through and find all the 7 plus 2s, then I find all the 2 plus 7s. They're not, as a teacher, this may be easy to enter into my grade book, but I'm not able to really get enough from my students in terms of what's really happening. So, we talked with Val in this season, episode 2, season 6, about assessing. And it's a really big topic. And I want to just directly address that, like, there's not only one way to address it, but I'll quickly share a story that I was in a TK classroom and I'd shared this story before. A little boy he was so excited to share 2 plus 3 is 5. And when he was at like, oh wow, well, how do you know? Like, could you show me with these cubes? Like, I'm so curious. And the little boy, palpable anxiety. He got so upset, and it's like he knew the rhythm, he knew the lyric, 2 plus 3 is 5, but it didn't have that meaning. And so in a TK classroom, I wasn't assessing him, right? But he shared it, and I was excited to hear, well, what do you mean? Say more. So when I'm thinking, I never forget that, because when I'm thinking about these students and as they're trying to make sense of it, I'm thinking, how are students making sense of these problems today? So as I'm walking around, as the students are playing games, I have my clipboard. I'm making little notes, or I'm flagging students that I want to highlight, that I want to go to and say, hey, can I share your work later during the share out? And so in this picture, in this example, a little girl is counting on her fingers. She's trying to figure out what would make a 5 as she plays the game Go to the Dump. So she had a 2. She's trying to figure out, how many more do I need to make 5, right? And so I can make a little note that she's still counting, and that's not wrong. That's not bad. I never want her to feel like she has to hide her fingers. Your fingers are a tool. You have 5 with you all the time. But I want to know, okay, so she's not fluent in that fact yet. Again, this is all just information, and I'm figuring out, how can I give more experiences where she's able to build that confidence with those numbers and that flexibility. And the picture on the right is of an older student who's also using his fingers to solve. And that was in a one-on-one interview. So, uh, in facts wise, something uh, that Dr. Henry found is the power of a one-on-one interview. And when you have 30 students, I know that can feel 35 students, it can feel so daunting. But I wanted to put these pictures side by side because, in one, I'm still getting information by walking around and observing the students as they're playing games, or by when they're coming up during, when I ask questions, or when we're playing a game on the rug together. And if I sit down with a student for 2 or 3 minutes and I'm doing that interview, asking them about how they solve a problem, or how did they know that, or what's this problem, and going through some math facts in a way that I just want to know, how did you solve that? Or and I see a student using their fingers, or a student says, well, I didn't know that, but I didn't know 8 times 4, but I knew 2 times 8. And if they're telling me the ways that they broke apart a problem and they're using derived facts, that's all information to help me understand where a student is on their fluency journey. So I encourage you to see that there are so many ways beyond a time test. And that, in that 2 seconds with that, watching that student, is going to give me way more information, no matter how many fun clip art things you find, right? Because you can find a lot. Here's monster math. Here's spooky addition practice. Here's one with the apple, it says move fast. No matter how many I give of these, I'm not getting that same rich information as that formative assessment I don't know how a student solved it. I don't know if a student, I might know if an answer is right or wrong. I might know that this student isn't completing this in the mad minute that I gave them, but it's not giving me that information. So I encourage you, when you're thinking about how you assess fluency, before you cut out all those ice cream scoops, before you print off or buy this on the Teachers Pay Teachers, you're thinking about, how can I assess in a way that's more authentic to the sense making in the community that I want to promote? And I'll briefly connect it to reading fluency. So often we hear teachers being excited or fired up about reading fluency, rate, accuracy, and prosody. That how and when we think about reading fluency, those are the markers where you most often hear. Rate how fast a student is reading, not speed reading, but are they reading at a rate of, like, they're able to quickly decode, or are there words that they are fluent, they just know? Accuracy, are they able to read a word correctly, understand the word, read it like it doesn't trip them up as they're reading through? And prosody, is it mimicking speech? Is it mimicking natural speech? And the thing with all of these pieces, it's all connected to comprehension, right? If a student is um, if a student's pacing is off, or if a reading is choppy, or students are having trouble decoding, then all of these pieces are going to limit their comprehension of the passage that they're reading. The same way that if a student is having to stop and count to get, you know, 4 plus 8, and stop and count, and first count 8 and then count 4. It's stopping the flow of the work that they're doing of trying to solve these problems. Um, Again, we talked about students who are fluent solve problems accurately, flexibly, they utilize appropriate strategy, and again, when I say speed, I'm not talking about time tests, but I'm talking about that feeling when you own it. I can tie my shoes pretty quick, right? I can now find middle C very quickly. There's certain things I'm fluent in and that don't require that mental load. And I'm moving towards fluency in other areas. So we want our students moving towards that so that they have those at their ready. They have those facts at their ready. And then we'll have time for like one or two questions, but I want to say briefly next steps. If you're like, I actively have the ice cream scoops on my wall, or I have my time test hot off the press for tomorrow, I encourage you, I'm not saying that you are harming your students necessarily. What I'm saying is, I encourage you to think about what fluency could look like. What could it look like? How do you teach fluency now? Before you go changing anything, what's the story of fluency at your school K through 5? If I'm a student and I start in kindergarten here and I go through 5th grade, how did I learn my addition, my subtraction, my multiplication, and division? Find another teaching partner, somebody who's interested in talking about this with it, and have a conversation. Examine fluency together. Find somebody in another grade and start talking about how you teach fluency and what feels effective and what doesn't feel effective. Find ways that right now you could use formative assessment data to plan strategic mini lessons. Could you do a number talk? Could you do some choral counting together? Is there just a chart that you are ready to put up on the wall tomorrow that you could co create with your students? Are there games that you can play where, as they're playing, you could walk around and collect data to see where they're at, to kind of do a pulse check of where your classroom is? And then make a plan based on research. You don't have to change if you're excited about changing fluency, or if there's things you want to tweak. You want to say, well, people have been talking about and thinking about this for a long time. Where's research that can help inform the decisions that I make as I make changes in how I teach fluency? Or maybe you're not yet focusing on fluency and you have it as something that you expect parents or caregivers to do at home. Is that something you could change? Or could you teach a game in your class that caregivers can then play at home? I think it's so important first that as teachers, there's so many things that we're carrying and that we're looking at. And at any one moment, there's a million things we could tweak. And so it's not about punishing ourselves for doing it when, oh, well, I've known time tests maybe are can be anxiety provoking, but I just didn't know what else to do. But hopefully you have a couple other ideas of what you could do, or some places you could look to find other things. And I really encourage you, when I say fake fluency indicators, this was a wonderful um, educator Dr. John Staley said, ditch the fake fluency indicators. Those time tests may look like they give you the fluency information you need, but they're not enough for our students. And I share some resources here, again, facts wise, Math Teacher Lounge. There's amazing books, amazing article by Joe Bowler, Fluency Without Fear, that I invite you to. It's free online. You can read it and dive in, start thinking more about fluency. And again, at MTL Show, Math Teacher Lounge. And oh, I do highlight there that we have a Facebook group, Math Teacher Lounge community on Facebook. And any questions that you ask that I don't get to, since we only have a couple minutes, I'll make sure to answer them over there in the Facebook community. And I have a list of the references from the amazing educators and folks who have shared their work. And I do want to take a second to see if there's a question or two I can answer before we have to sign off.
Well, thank you, Bethany. That was amazing. As always, wonderful tips, just packed full of tips. So I'll pull up the questions. We did have quite a few, but I know we only have a few minutes left. So see if we can find some easier ones to answer. And then, like Bethany said, we'll try to answer them.
Yeah.
In the Facebook group, Math Teacher Launch Facebook group as well. One question so that we get a lot at Amplify is connecting math and bringing numbers to a real world situation. What was the resource, which I know someone else asked to bring up the resources slide, but where do you find real world situations to connect math to?
Do you mean specifically like when creating problems? Is that, or was that what they?
I believe so. It's that, I mean, they didn't really go into detail here, but I know that we're always getting asked, how do you find these
Yeah.
situations? Like, besides just off the top of your head, like, where do you find ways to connect math to the real world?
Yeah, well, I think the most important place is from your students. What are your students talking about? What are they excited about? What are questions that they're asking about? Or let's say, is there a field trip you're going on, or is there a library at your school you're going to, and there's some problem you can base it off of something that's in your immediate environment or in your students' community. For example, I start the year doing a number hunt at home, and I just want them to start by looking for numbers at home, right? And then they're coming back and they're sharing where they saw numbers. Or I might give invitations to look for numbers at the grocery store, or numbers or problems based on a grocery store, something that all or at least a wide majority of my students have experienced. Most students have gone with a caregiver to a grocery store, right? Or all of my students have gone with us to the school library because we go every other Tuesday or whatever. So I want to look at what situation can I help make it real? Like, how can I make it real for the students and make the numbers mean something? The hutch came about, the rabbits in the hutch, when I originally did the problem with Dr. Jody Guarino. um, Two things. One, we were practicing digraphs, so we were practicing CH randomly, and hutch was one of the words that in like this vocabulary list. And we started talking about numbers and structure, and we both started talking about problems we've seen where students are trying to show the structure. And Dr. Guarino, neither Dr. Guarino nor Mrs. Minton have rabbits, but we're all, we start off by talking about pets and what pets do you have or what pet would you want. And then we say, what Dr. Guarino has? She has rabbits. And the rabbits are in the backyard. And sometimes when she goes out, they're in the hutch. And sometimes they're out of the hutch. And the students were so invested in this problem because it was connected to something real, right? And sometimes it's a matter of taking a problem from your textbook and just changing the context. You don't have to invent all these problems. Like, take a problem and add a context or switch a context. Or if the problem the textbook gives you is about, Disneyland, don't assume all your students have been to Disneyland, right? Or to whatever. Like, make it about your school or something that you know is in your community.
Wonderful. That was so helpful. Um, and I know we're at time. Uh, there was
But
one
Shannon
question.
will. Oh yeah, you want one more? Okay, sure.
Yeah, if you have
Yeah,
the time, there was one
yeah,
that was really
yeah, totally.
good. So you did a lot charting, which a lot of people respond to in the chat. And one person asked, when you are charting, are you organizing the data for students, or do you chart it the way they give it to you and then you have them organize it? And this person asked because when they did a sharing crackers activity with third graders, it was appropriate to jumble the ways they shared the crackers and then ask them to organize it. But they want to know if this is developmentally appropriate for even younger grades.
That's interesting. Yeah, so I think it really depends, right? So if I'm doing something like a number talk where I'm saying, we were doing a number talk with 10, and we are saying I wanted to know all the different ways that we could make a 10, right? And students were just shouting answers, right? Well, not shouting. I was trying to encourage them not to shout, but they were shouting, giving me answers, and I'm just charting it, right? My goal is just charting it, and I'm just charting what they say. And then with that, my goal is that we're just capturing the information. It's like, what's your goal of the chart? So if your goal is that you want to create a public record, something that's going to live in your classroom that you want students to reference and come back to, like in that case with like that, I had the 10 and then I had all of our charts and then I had put some post-its and students could come back whenever and go add more to it. So even though that was a public record of that activity, there wasn't a certain structure that I needed them to see. I just wanted them to start generating ideas of all the different ways we could make 10, and they were coming up with 3 plus 7. Oh, 1,000 minus, they all different ways, right? And that's just to record it and capture that moment. But in the case of, let's say, the rabbits in the hutch or the shaker, the counter activity that I'm doing, I really, and that my goal was that not only would they find all the ways to make five, but that they would start to see that structure. And the same with the 10. So that required me beforehand to think about the chart. So the first thing I would recommend is thinking about what's your intention for the chart? And then is there a way that you can organize the chart ahead of time. It doesn't have to be elaborate, but organize the chart ahead of time so that you can generate the information or you can have the record reflect a structure that you want your students to be able to see. And they might not see that structure initially, but somebody's going to say, oh, it looks like a stair step. Oh, it goes like this. So, and I think there's a ton of validity in having your students organize it later, but that's a different goal, right? So if I want to have the information and my students organize it, that can be really exciting because they're making sense of it. And you're talking about ways that they made sense of that information that then's going to live on a chart. So I don't think there's any wrong way to do it, but I think something that I learned and something I didn't previously do was I learned to try to be more intentional with my charting. And that did require, like when I'm planning, sometimes it would just be a quick little sketch of what the chart could look like. And again, because I don't feel super confident in my drawing ability, sometimes I would like trace something in pencil, like the hands, or you have a cutout of hands that you tape the picture, whatever works for you. But again, it's about what is your goal, and if it's something that's going to live in the classroom, I think there's such power in creating it with your students and something that they can reference. And so my students knew, oh, can you go find that on the chart? Or wait a second, does that reminds me of that activity? Why don't you go look at the chart and see what you find? See what you find on that. And they know where it is or they'll reference it later. But it's because it's not something that I bought and hung up. It's because it's something we created together.
Right. Well, thank you, Bethany, and we will collect
Thank
everyone's
you.
questions.
Yes.
Um,
And I will
and if anyone,
answer them in the Math Teacher Lounge Facebook page
yes,
as soon as I can within this week. And I really appreciate your questions and your time, sharing your time here.
yes, thank you, everyone. And there's some more links here. I won't go through all of them since we're so far over. But there is the link to the Math Teacher Lounge Facebook group at the bottom there, so you should definitely go check it out. Um, Thank you all so much, and hopefully we'll see you soon.